Now we are moving to the vertical fragmentation from 7th point onwards. So 7th point, in its simplest form, vertical fragmentation is the same as decomposition. Vertical fragmentation of small r of capital R, where capital R is representing, for example, we have banking enterprise. In the banking enterprise, database, capital R is nothing but a banking enterprise database, otherwise a banking enterprise schema. So in that schema, we have different types of R, small r relations. Capital R is nothing but a big enterprise is there, a big database is there. Small r is nothing but one of the table from that enterprise. Okay. Vertical fragmentation of small r of capital R, small r of capital R. Small r is nothing but one relation, any one of the relation table from capital R is nothing but from the entire banking enterprise. Otherwise from the entire student data. So one of the table means, for example, marks list table I am taking. That is a small r. So capital R is nothing but entire banking enterprise database schema, and small r is nothing but one of the relation, one of the table from that banking enterprise. Okay. So what are the examples? Small r is nothing but you can take account table, deposit table, loan table, there is borrower table. Otherwise, if it is a for example, student database is there, capital R, schema is there. So from the student database schema, small r means what are the different relations you are getting at the beginning. Okay, what are the admissions you got? That is one beginning table. Next, they have divided into different branches again based on that. Okay, the first year, second year, third years. Even though, okay, how many students are there, and based on the exams, how many different tables you are getting. Okay, so now even though exams have conducted, next above 75, below 75, otherwise who are failed or passed, already you know all these things. So based on that you are getting the different types of tables, means based on the conditions only you are getting different types of tables. So capital R is like the entire student database, otherwise the entire banking enterprise schema. Smaller is but one of the table. I think you understood. Now vertical fragmentation of small r of capital R involves the definition of several subsets of attributes. R1, R2, Rn of the schema capital R, so that capital R equal to R1 union, R2 union, up to union what? Rn. Now each fragment Ri of small r is defined by, here Ri equal to pi we are taking. Next, Ri of small r. The fragmentation should be done in such a way that we can reconstruct relation R from the fragments by taking the natural join. We have natural join, just you go to that natural join. The first voice record I explain everything, and even though you have the topic in the second unit. So, relation R from the fragments by taking the natural join. So how the natural join we can apply means, the natural join symbol here you have. So in the join we have leftover join, right over join, next full join. Okay, I explained with slides those joins. Maybe you have in the tables, maybe you have in your notes. Please check it once. Next in the point, one way of ensuring that the relation R can be reconstructed is to include the primary key attributes of capital R in each Ri. Means we are constructing any relation R. Means at that moment we have to apply one primary key and foreign key. Even though if we are going to reconstruct the relation R means, here we have to include the primary key attributes of capital R in each Ri again and again. Next, we are moving to the super key. Any super key can be used. It is often convenient to add a special attribute called a tuple ID to the schema capital R. Tuple ID means nothing but serial number, like that. Next, the tuple ID value of a tuple is a unique value that distinguishes the tuple from all other tuples. The tuple ID attribute thus serves as a candidate key for the augmented schema and is included in each Ri. The physical or global address for a tuple can be used as a tuple ID since each tuple has a unique address. Physical address or logical address. Okay. Now 13th, to illustrate vertical fragmentation, here they are taking an example. Consider a university database in the relation. Okay, we are taking from university database. Okay, one of the relation. With relation, what is the relation? Employee underscore info. That is the relation name that stores for each employee. Okay, underscore information is one of the relation that stores the employee information is having different types of attributes. What are the attribute names? Employee underscore ID, name, designation and salary. These four are important to every employee. Now this relation is fragmented based on these attributes. Vertical no, so that's why based on these attributes now it is fragmented. This relation is fragmented into relation. One more relation you are getting, employee underscore private underscore info, and one more relation name is in below the line only you have employee underscore public underscore info. So employee underscore private underscore info, that relation is having containing what you have, employee underscore ID and salary. Only ID and salary they are taking in the private employees information. And another relation employee underscore public underscore info containing attributes employee ID, name also they are taking and designation. Here they are taking what? Salary. These may be stored in different sites again for security reasons. Means if they are private employees, then they are storing in different site, and they are public employees. Public means they are what? Permanent employees. Then their information is storing in different site for security reasons. This is nothing but vertical fragmentation. I think you people understood.